Hi, today we're going to talk about the law of conservation of mass. So, in 1789, this guy, Antoine Lavoisier, came up with the law of conservation of mass. And basically, what it states is that in a chemical reaction, matter is neither created nor is it destroyed, but it is just transformed from one form to the other. For example, if we had 7.7 grams of sodium, shown here, and we added 11.9 grams of chlorine gas, shown here, what we end up with, we form a reaction forming sodium chloride, but we end up with 19.6 grams of sodium chloride. So matter in this case is neither being created or is it being destroyed, it is just being transformed from one form to the other. This is the basis of the law of conservation of mass. So, the law of definite proportions came about when Joseph Frost noted that while he was experimenting, that elements of a certain compound always seem to appear to react within a certain ratio, or their ratios appear to be fixed. And he came up with the law of definite proportions, which says that all samples of a given compound have the same proportion of their constituent elements, regardless of how they're sourced or how they are prepared. So, sodium chloride, which is made up of sodium and chlorine in a 1-to-1 ratio, will always appear in a 1-to-1 ratio, regardless of how you make sodium chloride. And that was called the law of definite proportion. The law of multiple proportions was proposed in 1804 by Mr. John Dalton. And what Dalton states is that when you have two elements that can combine to form two different compounds, for example, you know that when carbon combines with oxygen, you could form either carbon monoxide or carbon dioxide. When these two elements combine, the mass of element B that will combine with 1 gram of element A can be expressed as a ratio of small whole numbers. So later on, Dalton put all three laws together and he came up with what is now called Dalton's atomic theory. And it explains the laws as follows. 1. Each element is composed of tiny, indestructible particles called atoms. He also said that all atoms of a given element have the same mass and properties that distinguish them from the atoms of other elements. And atoms combine in simple whole number ratios to form compound. And fourth, atoms of one element cannot change into the atoms of another element. And in a chemical reactions, atoms can only change how they are bound together with other atoms, but they cannot change from one to the other. Now, subatomic particles. All atoms are composed of the same subatomic particles. These particles are the positively charged protons, the neutral neutrons, and the electrons. The number of protons in an atom defines an element. The number of protons in an atom's nucleus is what we call its atomic number. And we give this atomic number the symbol Z. So for example, helium, inside the nucleus of helium are 2 protons, whereas in the nucleus of a carbon atom are 6 protons. These numbers are extremely important for identifying atoms. All the elements are arranged in order of their atomic number, and this arrangement is called the periodic table. So essentially, when you view your periodic table, you will see them in increasing atomic number or increasing number of protons. As said earlier, the atomic number is given the symbol Z. Now, the mass number is another very important number when we are dealing with atoms and molecules. The mass number is the sum of the number of neutrons and the number of protons in an atom. And we represent the mass number with the symbol A. So mass number is equal to number of protons plus the number of neutrons. Now, isotopes. All atoms of a given element have the same number of protons. So every carbon atom will have 6 protons. However, the number of neutrons within an atom may differ. And the difference in this number of neutrons is what we call, or what is responsible for the formation of what we call isotopes. Atoms that have the same number of protons but a different number of neutrons are called isotopes. One very popular example of isotope is hydrogen. A nitrogen atom that has only 1 proton is called protium. The atom that contains 1 proton plus 1 neutron is called deuterium. And the atom that contains 1 proton plus 2 neutron is called tritium. Mass is a combination of the fractional abundance of all isotopes of that element, which is why we often say carbon has a mass of 12, whereas in truth, if you take into consideration the isotopes, it is a little bit more than 12. So the periodic table lists the elements, and each element is shown in the periodic table with the atomic mass, the atomic symbol of that element, as well as the atomic number for that element. The periodic table lists all the elements in order of increasing atomic number. And we divide the periodic table into 3 broad classes. We have the metals, the metalloids, and the non-metals. The metals are found on the left-hand side of the periodic table, and we are concerned mainly in this course about the group 1 and 2 metals, and they all have certain characteristics in common. Metals tend to lose electrons to form ions, which we call cations, and they're positively charged. The metals all have the characteristics of they tend to be malleable, they tend to be ductile, and they're often shiny. The nonmetals are found on the right-hand side of the periodic table, and these are poor conductors of heat and electricity, And when they undergo chemical reactions, they tend to gain electrons to form negatively charged ions called anions. In between the metals and the nonmetals are the metalloids, which have certain characteristics of metals and certain characteristics of nonmetals. And examples of metalloids are silicon, arsenic, and antimony. When elements in group 1 lose electrons, they tend to have a plus 1 charge or a 1 plus charge, whereas elements in group 2 have a plus 2 charge or a 2 plus charge, and the nonmetals that gain electron in group 6 tend to have a 2 minus charge, and the elements in group 7 has a minus 1 charge. All elements, metals and nonmetals, tend to lose and gain electrons in an effort to achieve the configuration of elements that are in group 8, or they're trying to be like the group 8 elements, which are very stable and do not often take part in many chemical reactions. So later on, we're going to learn about exactly why metals in certain groups form ions as they do, and it will open your eyes a little bit more about the importance of having these charges that metals and nonmetals have.